Good. Divide both sides by 2, and we would get x equals 5. We can always check our answer if we plug that back in. 2 times 5 is 10. 10 minus 6 is 4, and that's correct. So again, we added 6. We undid this subtraction first. Most of the time, you can undo the subtraction or addition first. Now, what would have happened if we would have divided both sides by 2? Okay, if we would have did that first. Well, remember, whatever you do to one side of the equal sign, you have to do to everything on the other side. So that means I would have to divide all of this by 2, and I could divide this by 2, which in this problem, it could work out, right? Because then you would get x minus 3 equals 2, because that'd become 1x, that'd become 3, that'd become 2, and then you would add 3 to both sides, and you would get 5, right? But most of the time, let's say I change the problem to this. Let's say instead of minus 6, I changed it to minus, 19, okay? And let's say you tried to divide everything first, right, by 2. If you try to do that first, that's a lot worse, right? Because that's going to become x. Now you're going to have a 19 over 2 equals 2, and you're going to have to add 19 over 2 to both sides, and it's not going to work out really well. That's why most of the time, if we can, we want to undo the addition or subtraction first. Because if it was this problem, I would then add 19 to both sides. That would give me 2x. That goes away. Equals 23. And then I would divide both sides by 2. And that's a lot easier than what I would have did the other way. Does that make sense? So almost all the time we want to undo addition or subtraction first. Let's look at one. I'll have you try it and make sure we're on the same page. So what's going to be one of the better ways to start this problem? What's going to be the first step here? Yeah. Yeah, I subtract 9. I'll undo the addition first. So I'm going to subtract 9 to one side of the equal sign means I subtract 9. Remember, I'm subtracting 9 from all of this, but I can't subtract 9 from that because they're not like terms, right? So I just do it once on one side of the equal sign, do it once on the other. 6, I'm still left at 3x, and that's now went away. And then, of course, to both sides to undo this multiplication by 3, I would divide both sides by 3, and I would get x equals 2. If I check my answer, I plug that back in. 3 times 2 is 6. 6 plus 9 is 15. Very good. Okay. So let's look at a case where it's a little bit different. If you had this problem, x minus 7 divided by 4 equals, let's say, 5. So I'm going to solve this equation for x. In this case, the division is affecting everything, right? It's affecting this subtraction problem. I can't just add 7 to both sides, because if I was going to have to add 7, then I would have to get common denominators, and then I can't add it to this x because they're not like terms, and it would get really messy, right? So I can't just add 7 to both sides, because the division is part of this subtraction problem here. Right? The division is affecting the subtraction problem. So in this case, it would be easier to get rid of the division first. How are you going to get rid of a division by 4? You're going to multiply by 4, right? So when you multiply by 4 on this side, that means you have to do the same thing the other side. And again, the reason I multiplied by 4 on this side was just to get that division to go away, to cancel those. I don't actually have to multiply it to these things because it's going to divide out to make 1. So all I'm left with here is now x minus 7 on this side, and I'm left with 20 on this side. Your final step then, undo the subtraction by 7, do the inverse operation of subtracting 7, and add 7. That goes away, and I'm left with x equals 27. Again, I like writing it downwards to keep track of everything. Some people write it to the side, and then they get confused with like equal signs. I like starting at the top and working down and just keep making it smaller as I go. Right? If I check my answer, 27 minus 7 is 20, divided by 4 is 5, so that'd be correct. Okay. All right, let's have you try a similar type. Say you had one like this. Solve that equation for y. What's going to be the best way to start this one out? Good. Multiply by negative 2, right? Because I can't subtract 3 because I have this division as part of that problem. Right? The division is affecting everything. So I'm going to multiply here, but I'm going to multiply by negative 2. The reason is because when you multiply negative 2 divided by negative 2, because I'm like multiplying here, right, it's going to become positive 1. So those two are going to divide out, which means I have to do the same thing the other side. So I'm left with y plus 3, and on this side I'm left with negative 14. And then I would just undo that plus 3 by subtracting 3. Y equals, if I'm in debt $14, I take away 3 more, I'm in debt $17, and that's my final answer. I can double check my answer if I plug that in here. Negative 17 plus 3 is negative 14. Negative 14 divided by negative 2 is positive 7, so that's correct. Questions with that? 2/3 times x minus 4 equals 2. We're going to solve this for x. What could I do here to start getting x by itself? Let's start getting x by itself. What's an option here? Yeah, if I can move this subtraction by 4 over, I can just add 4 to both sides, right? And that would get rid of that part. Again, I'm making the problem smaller. So that's a perfectly good way to do it. If you add 4 to this side, which means you add 4 to this side. What's left over? I have 2/3 x over here, and 2 plus 4 is 6 over here. And then from this step, we talked about this earlier, you have 2/3 times x equals 6. So, yeah.
You can change it to 6 over 1
Uh-huh.
and divide that from 2/3.
Very good. So we're going to divide both sides by 2/3 now, because we're going to undo this multiplication. And dividing by 2/3 is the same as what?
Multiply.
Good. Multiply by flipped or the reciprocal. Because this is going to become then 6 over 6, which 6 divided by 6 is 1x, which gets what we want. So then we have to do the same thing over here. So those divide out. 6 times 3 is 18. 1 times 2 is 2. 18 divided by 2 is 9. Okay? And that's my final answer. That's probably the way I would go about solving this problem, but let's try it and see if we did it another way at the beginning. Okay? Let's say we wanted to get rid of that fraction. We wanted to get rid of the 2/3 to start with. Again, that's probably the best way to solve that problem. But if we want to get this division by 3, what's the opposite? Well, let's just look at the bottom part. That's dividing by 3, right? So if we multiply by 3, that means we multiply all of this by 3, because whatever you do to one side, you have to do to everything on the other side. I can't just multiply this by 3 and leave the minus 4, because then that changes the problem. Whatever I did on one side, I have to do to the other. So if I actually multiply by 3 here, that's like 3 over 1. That would become 6 over 3, right? So that would become 2x minus, and you're just distributive property here, 3 times 4, 12 equals 6. Then it becomes just a multi-step equation. It's going to require one more step than the previous way. You could add 12 to both sides. That gives you 2x equals 18. And then you can divide both sides by 2. And you get 9, how we got before. Okay. But anytime you can, I would move over the addition or subtraction first, just because it's going to make the problem shorter and easier to work with.